Let's review some mathematical definitions beginning with the monomial. A monomial is a real number, a variable, or a product of a real number and one or more variables in which each variable is raised to a whole number exponent. Some examples of monomials include negative 12x cubed, 45a to the 6th b to the 7th, negative 8.9x, and the fraction 10/11ths. If we go back and look at those last two examples, remember that negative 8.9x is actually negative 8.9x raised to the first. And 1 is a whole number, we just don't have to see it. Just like 10/11ths is actually multiplied by x to the 0. And 0 is also a whole number exponent, but since x to the 0 is 1, we don't need to show any of that part. Now some examples that are not monomials would include 3x to the half, because we have a fractional exponent, and 5x to the negative 8th, because we have a negative exponent. Just remember that 3x to the half is actually 3 times the square root of x, just as 5x to the negative 8th is actually 5 over x to the 8th. When you refer to a polynomial, what you are referring to is the sum or difference of one or more monomials. We can classify polynomials based on the number of non-like terms. For instance, one non-like term is a monomial, two non-like terms is a binomial, and three non-like terms is a trinomial. Understanding numerical prefixes is very helpful here. But once you get to 4 or more non-like terms, we just usually refer to them simply as polynomials. We can also classify or name polynomials based on the degree of the polynomial. To find that degree, you have to find the highest degree of any term of that polynomial. Now, if you happen to have just a constant, that would be a degree 0, unless that constant happens to be 0, and then by definition it does not have any degree. If you happen to have a largest degree term being x to the first, you have a linear, and we call it degree 1. If the largest degree term happens to be x to the second, it's quadratic, and it has degree 2. Just like cubic is if you find x cubed, and then you have quartic for x to the fourths, and quintic's x to the fifths. And you can see that the exponent determines the degree. When classifying polynomials, take into account both the degree and the number of terms. But remember to combine like terms before you do the classification. Here are some examples. 6a squared. A squared is the largest degree term. It is of degree 2. There is only one term. We would call this a quadratic monomial. 14x plus 1, 14x to the first is the largest degree term. Its degree is 1 even if we don't see it. There are two terms. We'll call it a linear binomial. N to the fourth minus 5n squared minus 9. N to the fourth means this is a quartic, and with the three terms, trinomial. 12w to the fifth minus 12, this would be a quintic binomial. Y cubed plus 3y cubed plus 5y cubed. Before I continue on, I have to remember these are all like terms, and I should combine them. Take the 1, the 3, the 5, add them up, you would actually get 9y cubed, which makes this a cubic monomial. And then finally, 5p to the fourth plus 6p minus 7p plus 8p to the fourth, when you combine like terms, gives you 13p to the fourth minus p, which is a quartic binomial. Finally, we come to a standard form of a polynomial, specifically for one variables. Do not be overwhelmed with the expression. Just realize that a sub n minus 1, a sub n minus 2 are coefficients being multiplied to terms. Specifically, x to the n is the largest degree term, followed by x to the n minus 1, the next largest degree term, until you get down to the constant, which is a sub 0. Here are some examples. If you just have the expression 1, there's nothing to do, it's already in standard form. But if you have the expression 1 plus 5x, 5x is the linear term. It is of degree 1. That should come before a constant of 1, which is of degree 0, and you should write 5x plus 1. If you now have 5x plus 1 plus 3x squared, the quadratic term of degree 2, 3x squared, should now come first, and you'd say 3x squared plus 5x plus 1. 5x plus 3x squared minus 7x cubed plus 1. The cubic term, negative 7x cubed, of degree 3, would go first, and you'd say negative 7x cubed plus 3x squared plus 5x plus 1. Now when we get to our last example, make sure you slow down and realize, unlike all the other four examples, this one you need to combine like terms first. You have a negative 7x cubed plus an x cubed. This will give you negative 6x cubed. And then you can follow it up with the 5x plus 8x and say plus 13x.